Welcome to the video for section 4.3. This time we're looking directly at the page. Make sure that you have your note-taking with vocabulary handout for section 4.3. We're doing it this way because we're going to be doing work on the graphing calculator, and I am able to easily show you the keystrokes on the calculator with this setup. Okay, so you won't see my face this time. Okay, so in your own words, write the meaning of each vocabulary term, and we're given radical function. So what you could say for radical function is that this is a function that contains, I don't mean to sound silly, but it's a function that contains a radical, or you might say it's a function that contains a square root or a cube root or any nth root. So that might be a good way to say it. It's a function that contains an nth root or a square root. So however you want to say that. The core concepts that were given here. The parent function for the family of square root functions is f of x equal to square root of x, has this shape. It looks like a parabola lying sideways where only the top half of it is graphed. That's one way you might want to think of that. This is one that you need to know by memory. I don't know if you've done it in the past, but it's something that looking ahead to 171 that you would be expected to be able to recognize this shape as the square root function. And then the domain of the range for this one, because it's only in the first quadrant, the domain is x greater than or equal to 0, and the range is also y greater than or equal to 0. All right. And then over here, the parent function for the family of cube root functions has this shape. This time it looks like top of a parabola on the right side, and then it looks like the bottom of the parabola on the left side. So it gives us this sort of squiggle shape here. This time domain and range are all real numbers because the graph eventually would go up forever, it would go down forever, left forever, right forever. If you flip your page over, you'll see we're talking again about horizontal translations, vertical translations, reflections, vertical shrinks, horizontal shrinks, etc. This is all the same concept that we did back in chapter 2 and that you did last year, and it applies to any function. We're just going to be using it now with the square root functions. So you have this as a reference if you need to refer back to any of it, but just to remind you that with the horizontal translations, you would see that as an addition or a subtraction inside your function. And remember, the horizontal shifts are the ones that are backwards. So like x minus 2 would be 2 units to the right, x plus 3 would be 2 units to the left. The vertical ones would appear on the outside of the function. If you have square root of negative x, that would be a reflection in the y-axis. So if you're negating all the x values, you get a reflection in the y-axis. And here, if you negate the entire function, you get a reflection in the x-axis. So this is the same concepts that we talked about earlier, just revisited. Same thing with the vertical shrinks and the horizontal shrinks. The vertical shrink occurs when the horizontal shrink occurs if you see like a horizontal shrink of 1/3 would show up as the reciprocal being applied to the x only. And then with the vertical shrinks and vertical stretches, you don't have to worry about reciprocals. It's just the whatever factors that you're given. Okay, so let's go on and look at some examples. All right, so here, the extra practice page. First, we're asked to graph the function, then identify the domain and the range of each function. All right, so you can do a t-table and put some values in for x. Because this is a cube root function, the domain is all real numbers. So you can put in, I would put in maybe -2, -1, 0, 1, and 2 for your x's. And you can go straight to your calculator, type these in if you like. So, okay, so if I put -2 into my function for x, then that gives me the cube root. And when I do cube root, I can go to math and then choice 4. So cube root, and then inside I'm doing -3 times -2. So -3 times -2, close the parentheses, and then add your 1. Okay, that's giving me a value of approximately 2.8. If I put in -1, I'm going to do math, cube root, so choice 4. I'm going to do -3 times -1, which is 3. Close the parentheses, Make sure you close your parentheses here, your order of operations won't be correct, and then add 1 as the last step. That gives me approximately 2.4. If I put in 0 for x, I'm doing the cube root of negative 3 times 0, which is 0, and plus 1. That just gives me 1. If I put in 1 for x, I've got cube root of negative 3 times 1, so negative 3 plus 1. Approximately negative 0.4. And put in 2, so math 4. Negative 3 times 2, close parentheses, and plus 1. Negative 0.8, approximately. So let's see where this shows up on our graph. Put in my x and y axes in here. No, you'll notice I'm using an ink pen. I'm only doing that so this will show up clearly in the video. You need to be using a pencil. So let's graph these points, negative 2 and 2.8. Okay, and then negative 1 and 2.4. It's about right there. 0, 1. And then 1, negative 0.4 would be about here. And 2, negative 0.8 is about here. Okay, and you should notice that x cube shape forming here. We said that was like a squiggle shape. Okay, but if you look at the original that we were given, okay, the original had this shape where it was the top of it was pointing to the right. The top of ours is pointing to the left, and it's because of the negative right here. All right, number 2, we'll do a table for this one as well. So here, if I go to put this time, this is your exponent is 1/2. Now remember in the last video we said that if you're raising something to the 1/2 power, that means you're taking the square root. So you could think of this, if you want to, as g of x equals 2 times the square root of x minus 5, and then the minus 4 on the outside. Now because you're doing square roots this time, what happens? What if I go to put negative 2 in for my x? If I do that, if you want to go to the calculator, you'll have 2, and then this time I can go second x squared to pull up my x square root function. Put in negative 2 minus 5, close parentheses, minus 4. Okay? You're getting a non-real answer. Okay? Because you've got a negative inside your square root, and you can't do that. So negative 2 is not going to help me. Negative 1 is not going to help me. 0, if I put in 0 for x, I've still got a negative under the radical. I need to go all the way up to x equal 5 before I can actually take my square root. So I'll put in 5 for x, and then maybe do 6, and we'll see what happens from there. So if I put in 5 for x, you're going to do 2, second square root, 5 minus 5, so that's going to give you 0, and minus 4 on the outside, negative 4. If you put in 6, you've got 2 square root, 6 minus 5, which is 1, minus 4, negative 2. If I put in 7, 2 times the second square root, 7 minus 5 would be 2, minus 4. It's going to give me a decimal because 2 is not a perfect square. Negative 1.17. Suppose I want to get a whole number over here because I want it to look as accurate as possible. I need to get to, what if I put in an 8 for x, I would get 3 under my radical. If I put in 9 for x, then I'm going to get a 4. So that would be 2 times the square root, 9 minus 5, close parentheses, minus 4. It gives me 0. Okay, so that's what we need. Let's graph this. So 5, negative 4. And I'm going to have to adjust my scale this time because my x's go all the way up to 9. So I'm going to count by 2, 4, 6. I'm going to count by 2's on the x-axis. Y-axis will be fine, like it is. Okay, so I need 5, negative 4, so it's going to be here. 6, negative 2. Did I mess up? -4. 1, 2, 3, 4. Okay. 6 -2s here. And I want to do 9, 0, so that's going to be here. Okay, because I counted by 1s on my y-axis and 2s on my x-axis, it made it look a little bit funny, but this is my graph. If I had counted by 2s on the y-axis, it wouldn't look quite so steep. Oh, and we forgot to do the domain and the range. So going back to number 1, what was the domain for number 1? To me, I like to look at my picture. The domain is all possible x's. So because this graph goes left forever, right forever, my domain is negative infinity to positive infinity, or all real numbers. So x is, I got to remember how to write that. It would just say all real numbers, okay, all real numbers. I'm used to interval notation. So interval notation would be negative infinity, positive infinity. For the range, okay, the y values, even though these graphs appear to flatten off, they really don't flatten off. They still continue to go up and down forever. So your range is also all real numbers for number 1, because that's an odd index. All real numbers. Or you could say negative infinity, positive infinity. In number 2, our domain, our x's begin at this point, and here x was 5. So the domain here would be x greater than or equal to 5, or you could say bracket 5 to infinity. And the range, the y values begin at this point, and this y coordinate was -4. So y is greater than or equal to -4. And I could say square bracket -4 positive infinity. Okay, number 3, describe the transformation of f of x equal to the 4th root of 2x plus 5, represented by g of x equal -4th root of 2x minus 5. So comparing the two, the only thing that I see that's changing is the signs. Everything else is exactly the same. So that's telling me that g of x equals negative f of x. Okay? In other words, the only difference between these two functions is that the y's are changing signs, which ends up getting distributed to the whole thing. So the only thing that's changed here are the signs. The entire function changed signs. So this would be, if you go back to your rules over here, this is an example of this one right here, where the entire function changed signs. And this one was a reflection over the x-axis. It's a reflection in the x-axis because the entire equation changed signs all the way across. Number 4, write a rule for g if g is a horizontal shrink by a factor of 5/6 followed by a translation 10 units to the left of the graph of f of x equal cube root of 15x plus 1. So with a horizontal shrink, you're going to be applying, you're going to be shrinking x by the reciprocal of this 5/6. So where you currently have x is going to be replaced with 6/5 x. So you have 15, and then you got cube root. All right, and this is going to be g of x. What else is going on in it? Followed by a translation 10 units to the left. Horizontal translations are going to appear inside the function. So inside the radical, we're going to have to show a horizontal translation 10 units to the left. Remember, horizontal, you go in the opposite direction with your signs. So if it's going to the left, that means you're going to be adding 10. So you've got the plus 1 here already, and you're going to add 10 to that. So if I simplify this guy, I end up with g of x equals cube root 15 times 6/5 is going to be 18, so 18x plus 11. And that's my function. Number 5. use a graphing calculator to graph 8x equal y squared plus 5. Identify the vertex and the direction that the parabola opens. So in order to use our graphing calculator for this, we first need to solve it for y so that we can put it into the y equals feature. So to solve this for y, I don't know, you might want to go onto a separate sheet of paper to do this. I'm going to do mine on a separate sheet because I have no space here. So I've got 8x equals y squared plus 5. I'm going to solve this for y, so subtract 5 on both sides. You've got 8x minus 5 equals y squared, or you could say y squared equals 8x minus 5, just to make it look nicer. And then you're going to use the square root property. So you're going to take the square root of both sides, and when you use the square root property, you have to do plus or minus the square root. So you're going to do y equals plus or minus the square root of 8x minus 5. This we can type into our calculator as two separate equations. So we'll come over here. So for my first one, and before I do this, I need to look at my Windows settings. Okay. All right. So y equals, I'm going to do positive square root 8x minus 5. And then I need negative square root 8x minus 5. And graph. Okay, so what you're seeing here is you've got a horizontal parabola. Now they're asking us to identify the vertex and the direction that the parabola opens. It's easy to see which way my parabola opens. It opens to the right. So we'll say it opens to the right on our sheet. And you can put the graph on there as well. And I can see that it opens to the right. Okay, the way I found my vertex for this was I went back to the equation that I was working with. I know that a square root function, the original y equals square root of x, we know from the core concepts, is centered at the origin like this. Okay, and because there's no plus or minus on the outside of my function, I do not have a vertical shift up or down. So that tells me that my y-intercept is 0 because it's sitting here at the origin. So if my y-intercept is 0, that means I can solve for my x-intercept just by putting 0 for y. All right, so my y-intercept is 0. And then to get my x-intercept, I'm going to do 0 equals plus or minus the square root of 8x minus 5. If I solve this for x, then it'll give me the x-coordinate of my vertex. So I can square both sides. I'll get 0 equals 8x minus 5. Add 5 to both sides and divide by 8. So I can see that the vertex is occurring at the ordered pair 5/8, comma 0 here. So my vertex was 5/8, 0. And number 6, use a graphing calculator to graph x squared equal 49 minus y squared. Identify the center, radius, and intercepts of the circle. So first let's solve for y. Solving this for y, I can add y squared to both sides. And then subtract x squared on both sides. Take the square root, so you'll do y equals plus or minus the square root 49 minus x squared. Okay. Now this one, because it's got the x squared on the inside, this is not the x squared, this is not the square root function that we used in the previous, in number 5. This one's a little bit different. You may recognize this from Math 2. X squared plus y squared equal r squared. That's the equation of a circle with a center 0, 0, and the radius would be the square root of the r squared, where r is the radius. So this one is actually in that form. Looking at this, I know from this information that my center is 0, 0. My radius is the square root of this constant, so my radius should be 7. Okay, now I don't know if we were supposed to use that information for this problem, so let's look at the graph of this. Let's type it into the calculator. So we'll put in, for our first equation, we'll put in positive square root 49 minus x squared, and then we'll put in negative square root 49 minus x squared and graph. Okay, we are getting a circle. So my radius is 7, and you can see that on here. So you could use the trace feature if you wanted to find it. There you go. And you can see that when you're at that highest point, y is 6.995, and then it's even closer to 7 there. So the radius was 7. Draw my circle in. Okay, my center is at 0, 0. My radius is 7, and my intercepts occur here, 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 here. So those points would be, I'm going to put them over here. This one would be 0, 7. This one would be 7, 0. This one is 0, negative 7. And this one is negative 7, 0. Okay. Now, homework for this section is very short, on page 212, problems 3, 9, and 19.